we're now looking at scientific notation. So scientific notation is a way of writing very large or very small numbers. Now, there is scientific notation is a special notation. It's also called standard notation or standard form. I'm not sure if you've seen these in science yet, but here is an example. There's the sun, there's the earth. The distance is 1.5 times 10 to the power of 8 kilometres. So, distance from the earth to the sun is 1.5 times 10 to the power of 8. Does anyone know how I would write that as an ordinary number? What's 10 to the power of 8? It's 10 times 10 times 10 times 10. How many zeros? What's 10 squared? Tell me what 10 squared is. 100. All right, good. Just watching. 10 squared is 100. What's 10 cubed? 1,000. All right. So how many zeros does 10 squared have? And 10 cubed? So 10 to the 8 will have how many zeros? So that's really 1.5 times 1, 2, 3, 4, 5, 6, 7, 8. 1.5 times 100 million. That's the distance. So instead of writing it, I'm going to write this as an ordinary number. How do I write that as an ordinary number? You can do it on your calculator, or what would you do with that decimal place if you're timesing? If you're timesing by 10, you move the decimal place 1 to the right. If you're timesing by 100 million, you move the decimal place how many places? 8. I move it 8 places. So I go 1, 2, 3, 4, 5, 6, 7, 8. Imagine writing the distance. Imagine writing that distance like that. The distance from the sun to the earth. We write it as 1.5 times 10 to the power of 8 kilometres. If we didn't have this notation, this is how it would be written. It would be written as 150 million kilometres. So it's much easier to write it like that, 1.5 times 10 to the power of 8, isn't it? I'm just introducing this. I'm going to show you how to write them properly in a minute. All right? So it's just an introduction. Now, a human blood cell is what's called 7 microns. We're going to go through what all these units are. Or 7 times 10 to the power of negative 6. Now, what 7 times 10 to the power of negative 6 is? It's just an introduction. You know, with indices, what's 10 to the power of negative 1? What's the power of negative 1 mean? 1 over, wasn't it? Negative power was 1 over. That really is 7 times 1 over 10 to the power of what? 6. Yeah, which is really 7 times 1, it's really 7 divided by 10 to the power of 6. Isn't it really 7 over 1 times 1 over 10? So it's 7 over 10 to the power of 6. That's 7 over a million. I'm just showing you. How big is a human blood cell? 7 millionths of a metre. Just showing you. Imagine having to write it like that, which is, if I do work that out, I'm going to put it over here. I'm not actually teaching it to you yet. I'm just showing you why we have scientific notation. That is 0.00007. Imagine scientists writing that. The diameter of a human blood cell is 0.000007 metres. Instead of writing that, they write it like this, 7 times 10 to the power of negative 6 metres. All right? Now we're going to learn the rules for writing it. You don't have to understand it yet. You can just see how ridiculous it is to write that, 0.000007. By the way, how many significant figures?
1.
Good. Here, how many significant figures? 2, all right? But imagine writing numbers out like that and writing out numbers like this. This is why we need scientific or standard notation. So, how do we know how to write it? Well, there's a certain way we write it. So, because our number system is based on powers of 10, 10 squared, 10 cubed, etc., 10 to the power of 4, we can also write numbers as negative powers, you know, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3 as well. So to express a number in scientific notation, we write it in the following form. It has to be, now you need to listen very carefully, a number between 1 and 10 times 10 to some power. All right, so it has to be a number between 1 and 10 times 10 to some sort of power. Let's look at the two examples up here. Look, 7, is that between 1 and 10? Times 10 to a power. Sometimes the power is negative, sometimes it's positive. Here, 1.5, does that lie between 1 and 10? Yeah, times 10 to a power. I don't want to see 15 times 10 to the power of something or 0.1 times 10 to the something. No, the number's got to be between 1 and 10. So this is what we're going to do down here. So to write large numbers, which one do you think is the biggest distance? Distance from the Earth to the Sun or the human blood cell? All right, notice, tell me about the power for distance from the Earth to the Sun. Is it a positive power? And the human blood cell is a negative power. So large things will have the positive powers. Anything bigger than 1 will have a positive power. Anything smaller than 1, so all your decimals and very small quantities, will have negative powers. So to write a large number in scientific notation, we're going to follow these steps. Position the decimal point after the first significant figure and then multiply by a power of 10. I'll just show you. Where's the decimal point at the moment with the number 1500? I can't see a decimal point. Where is it? At the end. So you need to position the decimal point after the first significant figure, but I like to say position the decimal point so that you have a number between 1 and 10. To get a number between 1 and 10. Because that's what scientific notation is, a number between 1 and 10, to get a number between 1 and 10. So, position the decimal point, and if you do put it after the first significant figure, you will get a number between 1 and 10. So, here's the decimal point at the moment. How many places do I need to move it? So, I'm going to go big now. There's 1500. How many places do I need to move that decimal point? So it's here at the moment. Go back 1, go back 2, that gives me 15. Go back 3, that gives me 1.5. So 1.5 times 10 to the power of 3, because I moved it 3 places. Of course, it's a positive power because we're talking about a big number. Do not learn if I go to the left if it's a positive power. You'll get confused. All right? You'll get to the exam and think, is it when I go to the left or when I go to the right? Don't learn that. It's a big number. Bigger than 1, it's got a positive power. You just have to know how many places you jumped. So the next one, decimal point for whole numbers on the end. How many places? 1, 2, 3, 4, 5, 6, 7, 8, 9. If I stop there between the 6 and the 3, I've got 6.324. That's a number between 1 and 10, isn't it? Or I've moved it to after the first significant figure. I don't think you're going to remember that. If you just remember a number between 1 and 10, times 10 to the power of what? How many jumps did I do? 9. That's it. The number 75 is not a number between 1 and 10. Where do I move it? 7.5. How many jumps did I do? Times 10 to the power of 1. We know 75 is 7.5 times 10, don't we? 7.5 times 10 is 75. 1.5, 10 to the power of 3 is 1,000. 1.5 times 1,000 is 1,500. We okay? What about the next one? Where's the decimal point? After the 4. I've already got a number between 1 and 10. So 4 times 10 to the what? It's not 1. 0. I'm not moving it. It already is. What's 10 to the 0?
1.
Yeah. So 4 is 4 times 1. So that's a trick one, that 4 is 4 times 10 to the 0, but that is in scientific notation. So scientific notation, I want a number between 1 and 10 times 10 to the power of something. All numbers. Still the same rule. Move the decimal point so that we get a number between 1 and 10. None of these zeros at the beginning is significant. How many jumps and where do I want to jump to? Where am I going to put? So I'm going to jump 1, 2, 3. If I stop at 3, it's 0.5. That's not between 1 and 10. If I jump 4 places between the 5 and the 2, I've got 5.2 times 10 to the -4. Why is it a negative power? Because it's a small number, less than 1. Anything less than 1, negative powers. The number is how many jumps you had to make from where the decimal point is. With a decimal, you can see the decimal point, but with a whole number, you can't see the decimal point. It's at the end. Okay? So this one, how many jumps? 1, 2, 3, 4, 5, 6, 7 gives me 7.12 times 10 to the negative 7. What about the 0.34? How many jumps? 3.4 times 10 to the negative 1. Because I had, it's because I had to move it one place. So that's the 1. And this number is less, it's a decimal. Anytime you've got a decimal, any number less than 1 is a decimal. Got it? And this one, how many jumps? 2 times 10 to the negative 2. That's 2 times 1 over 100. That's 2 divided by 100, basically, which is 0.02. All right, now convert, we've got some mixed ones. Can I move? Convert these to scientific notation. So, is this going to be a positive or a negative one? How many jumps? 3 to 5.7. 5.7 times 10 to the negative 3. What about the next one? How many jumps? 1. 4.823 times 10 to the negative. Is the next one a positive or a negative? How many jumps? 3. I need to get a number between 1 and 10. So the decimal point's on the end, 9.428 times 10 cubed. The last one, it's 73 point. That is not a number between 1 and 10. Where are we going to move it to? 1 to make it 7.385 times 10 to the power of positive 1. No, that is that original number. Well, how do you get 73? It's 7.3 times 10. I moved, look at the number at the beginning. If it's a number bigger than 1, if it's a big number, it's positive power. Got it? If it's a decimal number, a decimal, 0 point something, it's a negative power. Okay, now, tricky. Write the following in scientific notation. Now we're going to combine what we did today and yesterday to 2 significant figures. You're going to do this in 2 steps. Just do scientific notation first, and then we're going to round the first number to 2 significant figures. So let's just go scientific notation first. What have we got? Positive or negative power for the first one? Good. How many jumps? 1, 2, 3, 4. 7.654 times 10 to the negative 4. Now that is not 2 significant figures. The 10 to the negative 4 has got nothing to do with 7 point something. I just need 7.7 times 10 to the negative 4. So that's got 1, 2, 3, 4 significant figures in scientific notation. So I only want 2 significant figures. Next one. Is this a positive or a negative power? Decimal point is on the end. How many places do I move? So it's 9.470 times 10 to the 3. At the moment, by me putting this 0 here, remember zeros at the end of a decimal, I'm saying I know it to that accuracy, right? Just got to be careful. But 2 significant figures, what do I do? 9.5 times 10 to the power of 3. So that ends up being, if I just looked at that as my number, that's 9,500. But the real number's 9,470. That's a rounded. See, once you round to significant figures, you've rounded off the number. It's not, okay? It's that's not a 0.6 recurring. Well, it might be. No, I don't know. I'd have to look. Let's do it as 0.6 recurring. All right? I just can't tell what it is. It could be. Let's pretend it's 0.6 recurring. 0.666, etc. Can you write that in scientific notation? I'll put the 4th 6 there. We don't want 3 6s. Right, go. What is it? Scientific notation. 6.666, etc. times 10 to the what? At the moment, I haven't rounded yet. I just want to write it in scientific notation. Is it a positive or a negative one? Because the first number was a decimal less than 1. Now I want 2 significant figures, which is 6.7 times 10 to the negative 1. Well, that's if the question was 0.6 recurring. I can't see what I originally did. So I've made it 0.6 recurring. And if you want to write that to two significant figures, it's 6.7. So it's been rounded off. Like it would have been 0.67, which is 6.7 times 10 to the negative 1. Can I move? The next one, 43,576 is a big number. How many places? 3,576 times 10 to the power of positive 4, which is two significant figures, 4.4 times 10 to the power of 4. So explain the difference between numerical expressions such as 2 times 10 to the power of 4 and 2 to the power of 4. Well, let's just work. See, when they ask you a question like this, I don't want a sentence. Work them out, and then you can write a nice little conclusion. So 2 times 10 to the power of 4 is 2 times 10,000. So we already said 10 squared was 100. 10 cubed is 1,000. 10 to the power of 4 is 10 times 10 times 10 times 10. It's 2 times 10,000, which is 20,000. And 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. So they're very different, aren't they? Now, how do you enter things like 2 times 10 to the power of 4 on your calculator? You don't go 2 times 10 y to the power of x button 4. You've got a special button. No, not that one either. There is an E button. Now, I'm going to need someone's calculator, please. That's the EXP button, yes. So, to enter, say, 2 times 10 to the power of negative 5 on the calculator, this is what you do. You go 2.4 and then you press the EXP button, or some people have a times 10 with a little box button. And then if it's a negative power, you press the little plus minus button. But on some calculators, it's just the little, it's different to it's the negative, the positive negative button, or the negative button, not the big minus, okay? So if you do enter, so that you know if you've done it right, can you write 2.4 times 10 to the negative 5 as an ordinary number? Do you know what that number would look like? You'll see in a minute. We still got to do it. 4 times 10 to the power of negative 5. So I go 2.4. Does that work? Yes. EXP. Instead of, you don't go times 10 y to the x negative 5. You just press the EXP button, this one, and you'll see a little E on your screen. And that's telling me EXP means times, it's an exponent, times 10 to the power of, it does that for me, negative 5. And it looks like that on that calculator, 2.4 e to the negative 5. If I press equals and change, it's 0.000024. And you know that that's 2.4 times 10 to the negative 5. The other calculator, for EXP, notice this calculator doesn't have the E, but it's got the times 10. And I go negative 5. So I still press the EXP negative 5, but notice this calculator, girls, look at the screen. It's got times 10 to the power of negative 5. I can press equals, but to get it back, shift, shift. No, I don't know how to get it back.
Why do we need to get it back?
Well, you don't need to get it back.
No.
Shh. The EXP button on your calculator will set up times 10 to a power for you. So, if you see on your calculator will only go to exponential notation when it's run out of decimal places. So if you do a calculation on your calculator, for example, if I ask you to enter, I don't know, something that's going to give you 0.0000000056, it can't fit that on the calculator. It will give you scientific notation. 5.6 times 10 to the whatever. So you'll notice with some calculations, your calculator will give you scientific notation. Other times it won't. The other way you can see it on your calculator is like this. 3.5e negative 7 also means 3.5 times 10 to the negative 7. Can we please, what I'm doing here, this is just a rough idea. What's roughly 3 times 4? Roughly. I mean, I'm rounding to I'm rounding to the nearest whole number. 3.12 times 4.2 is 12. From indices topic, what's 10 to the power of 4 times 10 to the power of 6? So see how that, I'm just rounding them to 1 decimal places, for example. You wouldn't do this. But look, 3 times 4 is 12. 10 to the power of 4 times 10 to the power of 6 is 10 to the power of 10. And we know we're not supposed to write it as 12 times 10 to the power of 10. It's supposed to be, what I'm doing here, sorry, 12 is a problem. I'm not supposed to write 12 times 10 to the power of 10. I'm supposed to write 1.2 times 10 to the power of something. So 12 times 10 to the power of 10, isn't 12 1.2 times 10? Do you agree? Times, that's 10 to the power of 10. Do you know what I've just done? I've changed that 12 to 1.2 times 10. This really, if you did it on your calculator, you should get something close to 1.2 times 10 to the power of 11. I think I've lost some of you. Can you just go to your calculator now and go 3.12 exp 10 to the power of 4 times 4.2 exp 10 to the power of 6. Your answer should come out in scientific notation. Does it? Those myself. So just ignore what I just did because I'll do it later in the page. Just do it on the calculator. What do you get? Times 10 to the 11. Did your calculator give you scientific notation? Yeah. The reason it gave you scientific notation, it can't fit 131 and the other 9 zeros on the screen. Why are there 9 zeros? Because you'd have to jump 11 times. So once I've jumped twice, you just fill in the zeros. All right? We still have to practice doing that. 3.12. Just press EXP, not times EXP. EXP automatically does the times the 10 to the power of. You just press EXP and then you put a 4 times 4.2. So you don't have to press the times. You don't have to press the 10. You don't have to press the power. You just go E, which is times 10 to the power of 6, equals 1.3104 times 10 to the 11. The E means times 10 to the power of. Okay, so my answer is 1.3104 times 10 to the power of 11. I'm sure you can write it down. I'm going to cancel and do the next one. You have to practice it yourself. 5.13. You just need to see me press the EXP. So I've done 5.13 EXP negative 5. This is 5.13 times 10 to the negative 5. So negative 5 times 4.07 EXP 7. So 5.13 EXP negative 5 times 4.07 EXP 7. Now, I'm going to do the answer, and I get 2087.91. I'm going to explain why. 2087.91. The reason I got that, just look at your powers. What's 10 to the negative 5 times 10 to the power of 7? Bases are the same, 10 squared. And then you've got your 5 times the 4. Don't know why we're getting 2000, but hopefully I entered it right. So if I go 5.13 times 4.07 times, I'm just trying something for a minute. I've got 9 times 10 to the 5 over 3 times 10 cubed. I want you to do this using index laws. What's 9 divided by 3?
3.
And what's 10 to the power of 5 divided by 10 to the power of 3?
10 squared.
Very good. And what's 3 times 10 squared?
300.
Now, do it on your calculator, see what you get. So you go 9E5 divided by 3E3. If you're doing it on your calc, got it? 9E5 divided by 3E3. And you get 300. But I'm just showing you. So I did it without a calc. And I'm going to do the next one without a calc as well. Watch. 12 times 10 to the power of 6 divided by 24 times 10 to the negative 3. I know it's a little bit tricky. We're just going to get an idea of what your answer is going to be. What's 12 over 24? How do you cancel that? A half. 1 over 2, a half. Look at the powers from indices. We've just finished indices. 10 to the power of 6 divided by 10 to the negative 3. What do you do with your powers? Subtract. So it's 6 take away negative 3 is what? Positive 9. Girls, that's not meant to be 0.5. Is that scientific notation, 0.5 times 10 to the 9? What is meant to be scientific notation? It's meant to be a 5 here, isn't it? I'm meant to have a number between 1 and 10, so this is what I'm going to do. I'm going to write that as, now you don't have to do this. I'm just playing around here. You just have to know how to do it on your calculator, right? But I'm just showing you, if I didn't have a calculator, how we could do it. 0.5, I'm going to write that as 0.5 times 10 times 10 to the power of 8. Do you think what I've written is right? Do you see what I've just done? See this 10 to the power of 9? I've broken it up into 10 to the power of 1 and 10 to the power of 8. Why? Because 0.5 times 10 is what? Times 10 to the 8. Now, because 0.5, see, I might ask you a question in the exam. 0.5 times 10 to the power of 9, is that scientific notation? No. I really wish this was the number 5. How do you make it into the number 5? By timesing it by 10. I just took a 10 from here. Well, I can't change the value of the same thing. I can't change the value. 0.5 times 10 to the 9 is the same as 5 times 10 to the 8. Because, see 10 to the power of 9, it's really 10 to the power, that's right, 10 to the power of 9 is really 10 to the power of 1 times 10 to the 8. And if I do 0.5 times 10, I get 5. So what I'm really doing is just taking one of the 10s from here and timesing it by the 0.5, and I'm left with 10 to the power of 8. Okay, I can tell you to do it like that. But if you had to explain it, that's really what I'm doing. I'm taking one of the 10s from 10 to the power of 9 and leaving 10 to the power of 8 and timesing that 10 by this. So I'm just showing you how index laws work with this. You probably don't have to do it. But if you do 12E6 divided by 24E negative 3, you should get, is your calculator doing 5 times 10 to the 8? Or is it going 0.000? Is it able to fit it in? I want you to do 12E6. So on the calculator, it's 12E6 divided by 24E negative 3. That's how you would do it. Is your calculator giving you an answer in scientific notation? It is? Is anyone's calculator? I think it allows, your calculator can give you 8 digits on the screen or 10. Once...
There's 9 on the screen now, so I think it's 10.
Yeah, so once you get more than 10 digits, it reverts to scientific notation. All right? That's why sometimes you get it in scientific notation and other times you don't. So once you're over 10 to the power of something...
Yeah, 10 is the last.
Yeah. Okay, girls, now. Girls, to compare the size of numbers, this is what we're going to do now. We're going to compare the size of all these numbers. To compare the size of numbers written in scientific notation, Obviously, the number with a higher power of 10, provided they're written the right way, will be bigger. So which one's bigger, girls? 2.2 times 10 to the 8 or 9.7 times 10 to the 7? Are they both in scientific notation?
Yes.
So the one with the more 10 to the powers of is bigger. So the bigger one is 2.2 times 10 to the 8. I'm going to write that out for you. How do you write that out, by the way? 2. I have to jump. So I have to jump 8 places. 1. I've jumped 1 and fill the rest in with zeros. 1, 2, 3, 4, 5, 6, 7, 8. That's the first number. Shh. Yep. 9.7 times 10 to the 7. 9.7 times 10 to the 7, we need to jump 7 times. So the point's there, that's 1 jump. Do you get that? And then how many more jumps? You just add zeros for the rest of the jumps. Now, which number's bigger? I should have lined them up. 1, 2, 3, 1, 2, 3. Which number's bigger? 220 million or 97 million? The top one. Can you see it's got more digits? So even though the 9.7 is bigger than the 2.2, that's not what you look at. It's the 10 to the 7. So look at these two. 2.3 times 10 to the negative 4 or 7.9 times 10 to the negative 5. They're negative powers. The negative powers have got more zeros in front of them. So let's write this one out. 10 to the negative 4. I have to jump back how many places to write down what the original number was? How do I do it? Do you know what this original number was? What was it? I have to go back 1, 2, 3, 4. There's the point. Let me check. 1, 2, 3, 4. Got it? That was the first number. Let's look at the other one. 7.9 times 10 to the negative 5. The point is here. I've got to go back 5. 1, 2, 3, 4, 5. There's the point. So these are my two numbers. Which one is smaller? The 79 is. Because it's 10 to the negative 5. It's got more zeros in front of it. I've just read. So, if they're all written in scientific notation, and they are, the 10 to the power of 8 one will be bigger. But the 10 to the negative 4 is a bigger number than 10 to the negative 5. You know how negative 5 is smaller than negative 4? With the negative numbers, it goes the opposite way. 10 to the power of negative 10's got lots of zeros in front of all your numbers. It's very small. Okay? What about these two? Which one's bigger? I'm going to write them both out. 1, 2, 3, 4. The first number is 1, 2, 3, 4. And the second number is 1, 2, 3, 4, 1, 2, 6, 5, 0. Which number's bigger? The second one's bigger. And the last one, oh, they're both 10 to the power of negative 8. I can write them. Which one do you think is going to be bigger? All right, let's try. 975. I've got to go back 8. 1, 2, 3, 4, 5, 6, 7, 8. Point. And the other one, 1, 2. Shh. Go back 8. 1, 2, 3, 4, 5, 6, 7, 8. Point. All right, let's count. Which one is... This is bigger. That's bigger because if I compare all the place values, I'm comparing a 9 with a 1 and the 9 is bigger. That is the bigger number. Very tricky. Look, watch. Just watch. Wait. Tell me what's bigger. Just watch this. What's bigger, 0.004 or 0.009? Same idea. One is this. Sorry, I shouldn't have circled that. I did say it was that bigger, didn't I? Yeah. Okay.